Welcome to Cint International Tutors. We are committed to bringing knowledge and skills to your doorstep. This is the second of our video series on how to clean data in SPSS. After watching this video, you will know how to clean data in SPSS. The first task that we're going to carry out is to identify and handle unwanted observations. Unwanted observations have two types, namely duplicate entry and irrelevant observation. A duplicate entry is an entry that has occurred more than once in a data set. And now we are going to open the SPSS data set to identify duplicate entry. The SPSS database has been opened. To identify duplicate entries in a data set, the first thing to do is to choose a variable that is a unique identifier for each person or case in the data set. For example, the participant's identification number. Next, click on the Data tab and click on Identify Duplicate Cases. The Identify Duplicate Cases box opens. Next, click on the identifier variable and click on the arrow to move it to the Define Matching Cases by box. By default, the variable that defines the duplicate cases is set as primary last. Click on OK. The output is shown on the viewer window, which indicates that there are 3 duplicate cases in the data set as shown. Similarly, the data view shows that the data set has been rearranged, with the duplicate cases appearing at the top. The duplicate cases here includes ID number 15, ID number 23, and ID number 29. You may wish to delete the duplicates or deselect them during analysis. To delete a duplicate observation, click on the row heading of the duplicate observation. Click on the Edit tab and click on Clear, Delete. Do the same thing for the second duplicate observation. And also for the third duplicate observation. Irrelevant observations usually occur due to entry errors, particularly for qualitative variables. For example, during data entry, whereas male was coded as 1 and female was coded as 2, irrelevant values such as 3, 4, 11, 22, etc. could be entered erroneously during the data entry process, especially where paper-based data collection was employed. Irrelevant observations in the case of categorical variables can be identified by doing frequency runs, and their locations can be identified by sorting the data in ascending order. To do frequency runs, in order to identify relevant observations for qualitative variables in SPSS, click on the Analyze tab. Click on the Stream Statistics and click on Frequencies. In the frequencies box that appears, click on the variable concerned, such as X, and click on the arrow to move it to the variables box. Then click OK. The output appears on the viewer window. The frequency distribution table for sex shows that there are 149 males, 136 females, and unwanted entries, such as 3, 2 of them, 4, 3 of them, 11, 2 of them, and 22, 2 of them. To identify the locations of relevant observations, click on the column heading of the variables concerned and click on Sort Ascending. The data is rearranged. The missing values appear first at the topmost part, followed by the other values, 1 for male and 2 for female. And then the relevant values, such as 3, 4, 11, and 22, and their location as shown. ID 178, ID 214, ID 239, ID 241, ID 274, ID 28, etc., etc. After irrelevant observations have been identified, the first thing to do is to confirm whether they were due to data collection errors or data entry errors. Those that were due to data collection errors should be removed, while those that were due to data entry errors should be corrected. The second task we are going to carry out is to identify and treat outliers. An outlier is an observation that lies abnormally far away from the other values in a data set. There are 2 types of outliers, namely outliers and extreme outliers. SPSS considers a value to be an outlier if it lies outside the following ranges: third quartile plus 1.5 multiplied by the interquartile range, or the first quartile minus 1.5 multiplied by the interquartile range. SPSS also considers a value to be an extreme outlier if it lies outside the following ranges: third quartile plus 3 multiplied by the interquartile range, or the first quartile minus 3 multiplied by the interquartile range. To identify outliers in SPSS, click on the Analyze tab, and then Descriptive Statistics, and then Explore. In the Explore dialog box that appears, click on the quantitative variable for which you want to identify outliers, and click on the arrow to move it to the dependent list box. Click on Statistics and put a check next to percentiles. Click on Continue, and then click on OK. The output is shown on the viewer window. The Tokisinji's row of the percentile table shows that the 25th percentile, that is the first quartile, equals to 24. And the 75th percentile, that is the third quartile, equals to 55. It therefore means that the interquartile range, that is the third quartile minus the first quartile, equals to 55 minus 24, that is 31. It therefore means that values that are outside the range of the third quartile plus 1.5 multiplied by the interquartile range, which equals to 101.5, or the first quartile minus 1.5 multiplied by 31, which equals to minus 22.5, are outliers. But since it is not possible to have a minus 8, it means there are outliers on the top side. Similarly, values that are outside the range of 55 plus 3 multiplied by 31, which equals to 148, or 24, being the first quartile, minus 3 multiplied by 31, which equals to minus 69, are extreme outliers. In the SPSS output, outliers appear as circles. It now means that observation number 256 and 292 are outliers. Also in the SPSS output, extreme outliers appear as stars. It means that observation number 234 and 187 are extreme outliers. After outliers have been identified, the first thing to do is to ensure that the outlier is not as a result of a data entry error. Then, you may wish to remove the outlier or filter it out if the value is a true outlier and could have a significant impact on the overall analysis. Another option is to assign a new value, such as the mean or the median of the data set, depending on the distribution of the data, that is, whether it is normally distributed or not, to the outlier if it occurred as a result of data entry error. The next task to be carried out now is to filter out outliers using the select cases function. To filter out outliers using the select cases function, click on the data tab. Go down and click on select cases. In the select cases dialog box that appears, select if condition is satisfied. And click on the if button. In the select cases if dialog box that appears, move the variable you want to give selection condition to, such as age, to the box. And enter the instruction. Since in our previous analysis, it was discovered that values greater than 101.5 are outliers, the condition to be given will be only values that are less than 101 shall be selected. Click on continue. Under output, by default, it is on filter out unselected cases. You may wish to delete unselected cases. But for the sake of this analysis, we are only interested in filtering out unselected cases so that they will not be included in the analysis. So click on OK. Scrolling through the variable age in the data view, it can be seen that both missing values and values greater than the cutoff for outliers have been deselected. ID number 112 with a missing value has been deselected. ID number 187 with a value greater than 101 has been deselected, being an outlier. ID number 234 with an outlier have been deselected. And they will not appear in the result of the analysis. Let us now play the box and whisker plot again to see if the outliers have indeed been filtered out. To create the box and whisker plot, click on the Analyze tab. And then Descriptive Statistics, and then Explore. In the Explore dialog box that appears, click on the quantitative variable be considered, that is age, and click on the arrow to move it to the dependent list. Click on Statistics and check the box next to percentile. Click on Continue and click on OK. The newly created box and whisker plot shows that there are no outliers, which confirm that they have all been filtered out. The next task to be carried out is to identify and handle missing values. In SPSS, there are two types of missing values, namely system missing values and user missing values. System missing values are values that are completely absent from the data. They could be due to the respondents not being asked some questions or skipping some questions or mistakes during data entry. System missing values, they appear as dots in the data view. User missing values are values that are invisible while analyzing or editing data, but they are in the database. So we are mainly concerned with system missing values. To find missing values in SPSS, click on the Analyze tab and then descriptive statistics, and then frequencies. You can either click on each variable and click on the arrow to move it to the variables box, or double click on each variable one by one to move them to the variables box. And then click OK. The output is shown on the viewer window, and the number of missing values are shown for each variable. Under age, there are 4 missing values. Under sex or respondent, 5 missing values. Under occupation, 3 missing values. Under tribe, 3 missing values. Place of residence, 3 missing values. Education level, 2 missing values. And so on and so forth. The next thing to be done is to know the identification number of the missing values. To know the identification number of the missing values, right-click on the column heading of the variables one by one and select Sort Ascending. The missing values appear at the top. For example, for the variable age, ID number 78, 112, 208, and 223 are missing. For the variable sex, ID numbers 151, 162, 129, 61, and 179 are missing. For the variable marital status, ID numbers 142 and 134 are missing. Likewise, you can do the same for the other variables. After identifying the system missing values, in the case of categorical variables, the first thing to do is to trace the data collection instrument to see if they are available and then enter them. If they are not available, the option is to exclude them in the analysis by computing the proportions based on the valid percent instead of the overall percent as shown. Similarly, after identifying the system missing values in the case of quantitative variables, the first thing to do is to trace the data collection instrument to see if they are available and then enter them. If they are not available, an option is to replace the missing values with values inputted from the observed data, such as the mean or median of all the observed data. To replace missing values for quantitative variables in SPSS, click on the Transform tab and click on Replace Missing Values. In the Replace Missing Value dialog box that appears, click on the variable concerned and click on the arrow to move it to the New Variables box. Go to the Name and Method section. Click on the arrow in the Methods box and select Median of Nearby Points. The Change button becomes active. Go to Span of Nearby Points and select All. Click on the Change button. Click on OK. The result is shown on the output view, and it indicates that 4 missing values for the variable age have been replaced. The data view shows that the missing values under the variable age, that is for ID number 78, 112, 208, and 223, have all been replaced in the newly created variable age 1 by the median of all the observations. Thank you for watching this video. I hope you found it helpful. If you would like to have additional explanations on the topics that have been covered, please obtain your own copy of the Student-Friendly Statistics for Health, Life, and Social Sciences book. The other form is available through the address shown. Also, I would like to inform you that the list of the Cint International Archive journals is available at the address shown. If you want to access our recently published articles, please do so at the address shown. And if you want to submit your manuscript to us for publication, please do so at the address shown.